This is a video for Edexcel Further Pure 1, Differential Equations, Section 1.2, Reducible Second Order Differential Equations. Let's consider two second order differential equations that are both linear. By that I mean that the highest order of derivative is d2y by dx squared, i.e. the second derivative, and linear means we haven't got expressions such as dy by dx all squared. The first one has got what are called constant coefficients, 5, -4, etc. And this can be solved by using your techniques that you've met in Further Maths Pure. The second one, however, is different in that the coefficients here, x squared minus 4x, these are variables, so they're not constant coefficients. And these cannot be solved in the same way as the ones that you've met already. However, sometimes they can be transformed into equations that we can solve by using substitutions. Now in doing this, we'll often be given equations such as x equals f of u, so a function of u, or u is a function of x as the substitutions. And we need to be able to get expressions for dy by dx and d2y by dx squared. Now to get dy by dx, we can use the chain rule. So dy by dx will be dy by du multiplied by du by dx. And that du by dx we can get from the functions x is f of u or u is g of x. Once we've got that, to get the second derivative, d2y by dx squared, we're going to have to find the derivative of what we've already done. So we're going to have d by dx of dy by du multiplied by du by dx. And this is going to involve the chain rule to be able to do the derivative with respect to x of dy by du, and also the product rule. Now let's illustrate this with a particular example. So we're asked to use the substitution x equals e to the u to find a general solution of this differential equation. So we're going to have to find substitutions to get us the second derivative and the first derivative. And let's see how we can do that. If x is equal to e to the u, then we can say that u is equal to natural log x, and therefore du by dx is equal to 1 over x. dy by dx, using the chain rule, is going to be dy by du multiplied by du by dx. So that's going to be equal to dy by du multiplied by 1 over x. To get the second derivative, we're going to have to differentiate that again with respect to x. So it would be the derivative with respect to x of dy by du multiplied by 1 over x. And that's going to involve the product rule. Firstly, we'll have d by dx of dy by du multiplied by 1 over x, and then plus d by dx of 1 over x multiplied by dy by du. So that's differentiating the first and multiplying by the second part, and then differentiating the second part multiplied by the first part. This bit here, differentiating with respect to x, I can do using the chain rule by differentiating with respect to u to give d2y by du squared, but then multiplying by dy by dx sorry, I beg your pardon, multiplying by du by dx, which is up here as 1 over x. So I get 1 over x, and that's what's in that bracket, but that's multiplied by 1 over x from here. And then add to that, the derivative of 1 over x is negative 1 over x squared, and we've got then multiplied by dy by du. So quite a complex bit of work we need to do to calculate the first and the second derivatives to be substituted. So make sure that you're happy with those two substitutions that we need to make. Dy by dx is dy by du 1 over x. That was just a simple chain rule. And the second derivative used the product rule and the chain rule to give us this expression. Well, now we can make the substitutions. So where we've got the second derivative d2y by dx squared, we can substitute this expression here. And notice that the x squared will cancel out. And then where we've got dy by dx, we can substitute this expression. And again, notice that the x's will cancel out top line and bottom line. So we end up with the differential equation being equal to d2y by du squared minus dy by du. That's from the substitution for the second derivative. We've then got plus 4 times dy by du. That's substituting for the first derivative, minus 4y is equal to 0. And if we calculate that and sort it out, we get d2y by du squared plus 3 dy by du minus 4y is equal to 0. Now the significance of that is that we've turned a non-constant coefficient differential equation in terms of y and x into one which has now got constant coefficients. So we can solve it using the methods that you've already met. So now that we've got this differential equation, it's a fairly standard method. The auxiliary equation is m squared plus 3m minus 4 equal to 0. That factorizes m plus 4 and m minus 1 equal to 0. And so therefore the complementary function is y is equal to a e to the u plus b e to minus 4u. But now we need to get it in terms of x. So remember that x was equal to e to the u, and therefore e to the minus 4u would be x to the power minus 4. So we have the equation, therefore, we have y is equal to a e to the u, which is ax, plus b e to the minus 4u, which is bx to the minus 4, or b over x to the power of 4. There it is, fully written out. So the hardest part of that is probably the initial part where we had to find the first and the second derivatives. And here it is once more, just for you to check through. We were given the substitution, and remember then that we had to differentiate using the chain rule. And then to get the second derivative, it required the product rule. and also the chain rule. But once we'd got those, we could then go on and make the substitutions quite straightforwardly. Those substitutions turned the differential equation with non-constant coefficients into one with constant coefficients that could then be solved using auxiliary equation. Well, that's the end of this video, and indeed it's the last of the videos in the differential equation section.